Hi everybody, this is Mr. Molikash again. This is our video for Math 171, Week 8. And just to kind of remind everybody who's watching this, this is my email address at johnston.cc.edu. So this week what we're talking about in Math 171 is a couple of things. We want to talk about issues with domain of functions. And the main issue, two main issues rather, with domain of functions is the square root and the fraction, right? So what are issues with square roots? Well, the inside of a square root, this is called the radicand, if you care about that. This cannot be negative. You get an imaginary number when you try to square root a negative, and those numbers are not in the domain of a function, right? And then the issue with a fraction is that you can't have a zero denominator. Can't have a zero denominator because if you divide by zero, you get something undefined. And for example, 6 divided by 0 is what? Well, if there was an answer to this, then 0 times that number would be 6. So think about that for a little bit and you'll see why that's undefined, right? So that doesn't make sense. So we can't do that either. So we'll look at a couple of examples of functions where we have to find the domain. Okay, and then the second thing we're going to do, we want to take up most of our time today, is with this thing called the difference quotient in section 1.8 of the Julie Miller book. Okay, so the difference quotient is really nothing more than the slope between 2 points. You might remember from early on in your algebra days, the rise over run, right? The y2 minus y1 over x2 minus x1. So we're going to make reference to that a little bit later. Our difference quotient looks a little bit more fancy than this, but this is really what it is at its root, okay, at the most basic level. All right, so let's look at the example of a couple of functions. Let's say we have f of x equals the square root of x plus 3. And we want to say, okay, what's the domain? Well, right off, we need to look at that stuff underneath the square root, and we need to say, okay, it cannot be negative, right? Well, not negative means either 0 or positive, right? So what we're going to say about that x plus 3 is that it's equal to 0 or greater than 0. And so we can immediately solve this by subtracting 3 from both sides, and this is our domain, right? Now, this is an inequality. This is one way to write the domain. In interval notation, if you're asked to do this in interval notation, you would start with -3 in a bracket, and then you would go to infinity and beyond. Buzz Lightyear to the rescue. No, just kidding. But infinity has does not have a bracket because you can never get there, right? So that's the and beyond thing. All right. So this is what we call interval notation, and you may be asked to write the answer in that way. Okay. Okay, let's look at another one that's a fraction. So let's say we have g of x is 1 over the square root of x plus 3. Okay, so now remember that we're not allowed to have a negative number under the square root, or that was what we just talked about in the previous example. But remember also that what we said in the previous page, that's the denominator can't be 0, right? So along with this, we also can't have this quantity being 0. So when we say that this cannot equal 0, right? So you can square both sides and subtract 3, right? So x can definitely not equal -3. Plus, remember, x had to be bigger than -3, as we already talked about earlier. So the domain for this one and I'm still writing in red, sorry about that. But the domain for this one would be a parenthesis -3 to infinity. And the reason for that is because you can't use -3 in the place of x, or you get 1 divided by 0, which would make the universe explode. So don't do that. All right, so here's our domain for g of x, okay? In interval notation. The other way it would be, x is greater than -3, okay? So those are a couple issues you'll have to encounter this week with domain of functions. Okay, so back to this other thing called the difference quotient, right? Let's say that we have a graph, and the graph has 2 points on it, and normally we find the slope between these 2 points by counting the rise and the run, right? But let's say that these 2 points are, they lie on a function, something like this. Some kind of function that is curved like this, right? So what we're going to do is we're going to call this value x. And if I put x into my function, this is f of x, right? Or y equals f of whatever x is. So this quantity, whatever this x is, this quantity is f of that x. So if this is 2, I put 2 into the function and I get f of 2 for the y value. If this is 18, a little further down the road, I put 18 into the function and f of 18 is the y value, and so on and so on. So this other x coordinate is more than x. So we're going to say it's x plus a little bit extra. And h is the difference between these x coordinates. So if you add x and h together, you wind up being at a place that's x plus h. So for example, if x is 2 and h is 1, 2 plus 1 would be 3, right? You'd be 1 unit past 2 to get the 3. So what would this be called? This is f of that new thing, right? All right, so the slope is called a difference quotient. It's very, very important when you get to calculus, okay? It's the thing that we use to find what we call a derivative in calculus. So the difference quotient is the rise. It's the difference in the y coordinates. So that's y2, if you will, minus y1 divided by x2 minus x1. And you might be tempted to try to simplify this numerator. Don't do that. The x's or the f's don't cancel out. You actually have to subtract 2 different things up here. And some things may cancel out, but don't cancel out the f's or the x's before you get started. Okay, so we're going to do an example real soon, and I'll show you that. All right, but what does cancel out down here on the bottom is you have x plus h minus x, right? And the minus x and the positive x do cancel out. Okay, so the formula for the difference quotient is actually f of x plus h minus f of x. So that's the distance between the y coordinates divided by the run, which is the distance between the x coordinates. And we already said that was h, but now you can see y. Okay. All right, so that is what we're going to use for the difference quotient. Very important. Let's look at a couple of examples where we have to calculate this as a function that's made from a given function. All right, so for example, let's say that f of x is x squared, and we want to find the difference quotient for this. Okay, f of x is x squared. We want to find a difference quotient for this. So what we're going to do is we're going to write down our formula. Okay, and I'm going to circle a couple of things. So first off, I know what this is. This is x squared. You can see that, right? F of x equals x squared. So in the place of f of x, I'm going to put what the function actually is. And I'm going to subtract that from something else that I'm going to calculate over here. So the thing that I have to calculate is f of something different. And the something different is going to replace what x used to be. The domain variable or the input is now going to be this x plus h thing. Okay. All right. So the f of x plus h, which I'm circling now, that's going to be this new thing, this x plus h squared. Okay, and I have to divide that by h. So now what I have to do is work out the algebra. I have to multiply x plus h by itself. So I can do that using the distributive property, right? I get x squared plus x times h is xh plus h times x, that's another xh, and then h times h is h squared. And then these two things are, like terms, so there's two of them. Okay, so that's what goes here. And then originally we had our minus x squared, so I'm going to do that and then divide all this by h, right? Okay, so what happens up here? Well, the x squared and the minus x squared cancel out. Amazing, right? So now what we have is 2xh plus h squared divided by h, right? All right, so notice that both of the terms in the numerator, that one and that one, both have an h. Well, dividing them both by h means that one of the h's cancel out in each one. So the answer to this is 2x plus h. H divided by h is 1, and h squared divided by h is h. And this is the answer, and we're just going to say on top of this that h cannot equal 0. So this expression only holds when h is not 0. If h were 0, we'd get 0 divided by 0 and the universe would explode. So we need to make sure that we're not using 0 for h, and that's got to be part of the answer. Okay. So what does this thing represent? This is a function or a formula that represents the difference quotient for f of x equals x squared. And again, if I'm going too fast, wonderful thing about videos is you can go back in time and rewind and replay stuff. Okay, we're going to do one more example here. Let's say that we have g of x equals 1 over x. And we want the difference quotient for this, right? So we're going to write down our difference quotient formula, and this time it's g of x plus h minus g of x over h. And you might say, gee, Mr. Molikash, how are you going to do this? Well, first thing is first. Just like I did the last example, we're going to get rid of that and put 1 over x in the place of that little circled thing, right? And we're going to subtract it from something else. And then we're going to divide all that junk by h, right? And I know this looks weird. You have a fraction over a fraction, but never fear. We're going to get rid of those fractions in a hurry. I have a neat little trick that I'm going to show you on how to do that. Okay, so what do we have to calculate here? Well, we have to figure out g of something else. The x is going to go out and sit on the bench, and we need to substitute something in the game for x, right? So that person that's coming off the bench to replace x is x plus h. All right, so that's our thing that we're going to put here like this, right? Okay, so here we go. We have to simplify this and take a deep breath and tell yourself it'll be okay. I know this looks crazy, but it'll be all right. So what we're going to do is we're going to get rid of these fractions. And the way that we're going to do that is we're going to multiply the top and the bottom by both denominators up here, x plus h and x. So I'm going to multiply by x and x plus h on the top and the bottom. You might be asking why that works out. Well, the reason that works out is because if you, let me cover up the bottom just a little bit. This x will cancel that x out, and so that fraction will go away, leaving just x plus h. And the x plus h will cancel this x plus h out, leaving just the x. So if you multiply this stuff and this, the x plus h's cancel out, right? So you just get x times 1, which is x. So again, let me kind of show you what we did there. All of that times all of that makes the x plus h's cancel out, and you're just left with x times 1, which is x. All right, minus. Now we're going to do the same trick here. What cancels out in this multiplication problem? Just the x's. So you're left with 1 times x plus h. Now, don't forget there was stuff under my red pen here that goes on the bottom. So we have h times x, and I'll put the x in front of the h, I guess. I don't know. Doesn't really matter. H times x, I'll leave it where it was. X plus h. All right. So now what we're going to have to do is distribute this negative, and it's very important too that in this problem here that I left the x plus h in parentheses because I want to subtract that entire thing, and therefore I'm going to have to distribute a negative sign. Many students forget to do that, so watch out. All right, so we're going to get x minus h over h times x plus h. Okay, so what does that make? Well, x minus x is 0, right? So now I have negative h divided by h, and that h divided by h is not 0 but 1. So the answer to this is negative 1 divided by x times x plus h, with the restriction that h cannot equal 0. So there's the answer. And this is, again, this is the difference quotient. Let me move this back over here. This is the difference quotient function for g of x equals 1 over x. Okay, so there you go. That's what we're looking at in week 8. Hope you have a great week, and don't forget the discussion boards if you need help, or you can send me an email. Have a great week.